So this is graphing linear equations in 3 dimensions, or 3D. So here's 3 equations right here. Z equals 4, there's equation 1. Equation 2 is y is equal to 2. And equation 3 is x is equal to 1. And I am going to say that these are 3 different planes if you look at these in 3 dimensions. So what is z equals 4? Well, here's our z-axis. Here is z equals 4. And just to think about 3D, it's this idea of having this, you're graphing sort of in this box. So the origin, x equals 0, y equals 0, and z equals 0 is right here. And as you move this way on the z-axis, you're moving positive, and if you go down, this is dashed because you can't really see it. If this box is really here, it'd be below the xy plane, which is this area here. It would go negative. And likewise, there's a y-axis that shoots out the back that way, and an x-axis that it continues to go that way. Okay, so z equals 4. And this is a plane. It is a plane that is exactly 4 units above the x, y plane. So you can imagine the x, y axes form a flat plane, and then so z equals 4 is just take that plane and raise it up 4, and this does in fact go out forever, right? Just like lines would go out forever. Planes also go out forever. I did not put any restriction on x and y. No limits to like with an inequality. So x and y could be anything as long as z is equal to 4. Okay, so there's z equals 4, and maybe I'll color it in. I'll color it in red. So there's that. And we just have to be careful because so there is our z is equal to 4. I'm going to try not to make this too hairy that we can't see it. What about y is equal to 2? Well, likewise, we're just going to go down to this y equals 2 spot right here, and sort of turning this on its side, turning our thinking on its side, we can imagine this other plane, y equals 2 plane, which is also parallel to this x, y plane, or it's just above it. It's just shifted up to y equals 2, and that one I'm going to do in green. We can also already see that there's going to be this intersection right here. So I'm gonna color this this way. I'm going to somehow color it this way. And this is kind of facing us. And where is the intersection of these two? These two planes intersect right here along this line. Just to take this out for a second, this y equals 2 plane looks like this, and the z equals 4 plane looks like this, and they intersect right along that line, and that z equals 2 plane continues out. So this black line corresponds to this black line, the intersection of the 2 planes. Well, the next step is to think about this x equals 1, which I put in blue. Put that like that. And how does that one look? Okay, so this is, again, we have to kind of stand on our x equals 1, right? Stand on our side and look at this plane right here at x equals 1, and how would that cut out? That would cut out right along like this ish, and I'll do that one in blue. I'll try to shade it in blue so that it's again. So this plane that I just cut out here is parallel to the plane formed by the zy axis, and it's just here. If here's the plane formed by the zy axis, just trace these lines right here. I just moved it 1 unit. I just moved it 1 up, and just like the other planes, they shoot off in all directions. Now we already Here it is on this picture. We already found the intersection of these two. And let me color it in. Maybe that'll make it see what the intersection of that would be like. Let's do, so it's this plane right here. Right? And we have an intersection right here at that one point. What's the coordinate of that point with this crazy diagram I just hopefully didn't lose you on? What's the coordinate of that point? That point right there. On this hopefully a little bit easier to see diagram. That point is x equals 1, y equals 2, and z equals 4. You know that point right there. It's a, you just read it right off of that. Okay, hope that wasn't terribly confusing. These planes are really hard to graph in 3D without some sort of animation software. So let's look at the next one. How do we shift down here? So these are equations of two other planes. We have x, y, and z, and I say twice x plus y plus z is equal to 4, and twice x plus y plus z equals 8. Well, something sneaky is going on here. If we consider this as kind of a standard form, if we made x and y 0, so we're on the z-axis, then z equals 4. So that would be the intercept right there. Z equals 4. If we made y and z 0, so we're on the x-axis, we see x is equal to 2. So there's another point we have on our plane. And if we make, what's the next one, z and x 0, you can just read that y is equal to 4. So that right there. And now we have really 3 points in space will form a plane. And again, this may look like a triangle, but this in fact does go out forever. And because, I mean, just think about it, there are other x, y's, and z's, negatives and positives that satisfy this condition that twice x plus y plus z equals 4, and all of those x, y's, and z's would be on this plane. So this would, I don't want to draw it, but this would shoot out this way, and it would also you can think of it shooting out that way, and it would still fill in up here, but this triangle. This plane is not just this triangle, but what's going on with this next equation? Again, standard form sort of thing here. If y and z are equal to 0, we're on the x-axis, we see x is equal to 4. Here we go, z-intercept is equal to 8. So that's right there. And the y-intercept is equal to, when x and z are 0, y is equal to 8. So that would be out here. But what's going on with these two planes that I'm representing by triangles? These two planes, no matter how far out they go, will never intersect. There's no solution. You could imagine if we did elimination here, right? There's no intersection of these, just like there's no solution here. If we subtract one equation from the other, we would get 0x plus 0y plus 0z is equal to -4. And so there we have no solution. This is just two planes. Okay, there are more to come.